Welcome back, ladies and gentlemen. Today we're going to talk about the first section of Chapter 11. We're going to talk about the area of parallelograms and triangles. Stuff you probably already know. We're just going to take it up a notch, so be prepared for some new information. Up on the screen, you'll see your exit question, as always. First, we're going to start with some postulates. Remember, postulates are things that we basically assume to be true without any sort of proof, reason, or explanation. Just stuff that is true for the sake of it being true so we can get on with it and move on to more complicated stuff. First, postulate 24, the area of a square is the square of the length of one of its sides. Simple enough. All right, area congruence postulate. Two congruent polygons are congruent. They must have the same area. And then the area addition postulate, which basically says that you can find the area of a complicated shape by adding all its pieces together or subtracting parts from it. Next, we got to define area. Your official definition of area is the number of square units needed to cover a region. We're going to use this definition to define the area of a rectangle. Okay, so this is theorem 11.1. The area of a rectangle is base times height. And the way you work from this definition of an area to the area of a rectangle is you divide the rectangle into little 1 unit by 1 unit chunks like that. And you basically picture it as a grid. You count them all up and you get your area of that rectangle. Even if there's a partial unit left over, you still count that partial unit, but it's still base times height. The other thing that I want to draw your attention to is that you may remember the area of a rectangle as length times width. Well, we're going base times height, and we're going to be specific about that for reasons that will become clear later on in this video. So let's start talking about a little more complicated shapes than rectangles. Let's start with a triangle first. Okay, how do you find the area of a triangle? You probably have that formula memorized. But where did it come from? How do you get it? This is what I'm going to show you right now. So here's a triangle. It has some base, which is some side that you decide to be its base. And then the height of the triangle may or may not be contained within the triangle itself, but the height of the triangle is how tall the triangle is. Pretend, flipping this up on the ground, measuring how tall it actually is. Well, to kind of derive how to get the area of this triangle, we have to go back to the only things we know, the postulates. Well, the postulates that we have says we know the area of a square unit. Then we build off of that and we get the area of a rectangle by adding a whole bunch of those square units together. So our triangle area formula has to be built upon either the area formula for the rectangle or the area formula for a square. So this is how you get from a triangle to a square. So first off, we copy the triangle and we make two of them. Put them together like that. If you then do some congruency theorems and that sort of thing, you can prove that the opposing sides of that shape, that compound shape now that the outer shape is a parallelogram. So basically you get a parallelogram with a height the same as what it was over for the triangle and the other side, a base of length b, the same length of the base as a triangle. And you might say, well, hey, that's still not a rectangle or a square, so we still don't know that. So we need to work on the parallelogram and try to work that into a rectangle. How do you do that? Well, you chop off a corner and you move it over like that. Now we have a rectangle with one side, its base being b, and the height of it is the same height as our original triangle. So what does that mean? Well, it means that the area of a triangle is really half the area of a parallelogram, and the area of a parallelogram is the same as the area of a rectangle as long as that rectangle and the parallelogram have the same height. Okay? It's really super important to note that the area of a parallelogram and the area of a triangle don't depend on a side length for its height. It depends on how tall the actual shape is. So the outer shape, the parallelogram, is as high as h, and the triangle is as high as h, but neither shape use the actual length of the side right here. So a common distractor is for them to give you a problem with every side labeled, and you have to figure out which numbers you need in order to calculate that area. So that works out to be two area theorems, 11.3 and 11.2. Not necessarily in that order, apparently I reversed them. But the area of a parallelogram is simply base times height, where the height is how tall the parallelogram is, and the area of a triangle is base times height divided by 2, or 1/2 base times height, or 0.5 times base times height. Your choice. There it is for you. Let's talk about doing area calculations as a geometry student. We're going to move on from decimal answers, basically. Every answer that you give me in this chapter needs to be exact. Now, what I mean by that is you can never round or truncate a decimal. So no rounding decimals, and truncating means to cut it off before the actual number ends. So that means that if an answer that you get fills up your calculator screen, you can't just write out every single digit on your calculator screen. You have to give me an exact answer. So if you have a decimal that ends on its own, like 8.125, and it stops, that's an exact answer, and that's okay to leave it as. Or 3.5, that's an exact answer, and it's okay to leave it like that. But if you see your calculator screen going 6.333333333 forever, you can't just truncate it at that last 3, or even write the 3 with the bar over the top. Some people will accept the bar notation. We're not going to do that. We're going to express every answer that we have that might be a repeating or an irrational decimal. We have to express that as a fraction or an improper fraction. Or if it contains a radical, you have to put it in simplest radical form. Or once we get to circles, you're no longer going to be allowed to convert pi to a decimal. You're going to leave pi as pi, and you're going to speak of area in terms of multiples of pi. We'll get to that when we talk about circles. I'll explain that further. But for now, you need to know that anytime you get a repeating or irrational decimal, you need to express it as a fraction or a radical in simplest radical form. And then secondly, a note on labels. We're going to be dealing with area, volume, and surface area, and lengths for that matter. So first off, don't forget units. Pretty much every answer you're going to give me in this chapter will have a label attached to it. Length is measured in units. So if our drawing was given to us in centimeters, length would be measured in centimeters. Area is measured in units squared. So again, if your drawing was measured in centimeters, this would be centimeters squared. And volume, when we get to volume, will be in whatever units it's measured cubed. So centimeters cubed in the example that I gave. Let's do a problem. Here it is. Why don't you pause the video and see if you can get me the answer for this problem. You're going to learn to hate and then love that word right there. Find an exact area of the shaded region. Pause the video and see if you can do it. Okay, first off, the shaded region, we need to basically take a rectangle and subtract the area of the triangle in between. To do that, we're going to use the two formulas, base times height minus base times height divided by 2, or 1/2 times base times height, however you want to remember it. So that means we're going to need the dimensions of that triangle. We're going to choose one of them to be the base, one of them to be the height. The hypotenuse isn't terribly useful to us, but let's figure out the dimensions of that triangle. That's the tough part. See if you can pause the video and do that. Because we know that there are 4 right angles here, this is a rectangle, so that means opposite sides are equal. So this is 32. And since this is a 30-degree angle and that's a 90-degree angle, that's a 60. So this is a 30, 60, 90, which means that the hypotenuse and the short leg have a 2-to-1 ratio, and the short leg to the long leg have a ratio of 1 to the square root of 3. So from the 32, we chop that in half to get 16, and then we take 16 and multiply it by a square root of 3 to get there. So our triangle overall is 16 by 16 times the square root of 3. So we plug those into our formula. Base and height of the rectangle are 21 and 32, minus 0.5 times 16 times 16 times the square root of 3. Don't give me a decimal answer. Give me an exact answer. So we're going to keep the radical in there, which means that you can't make it look all nice and pretty, but you can simplify it down. Just basically multiply all those numbers together, leave the square root of 3 alone, and you can multiply those two together. You cannot combine these terms because they don't have the same radical parts. They're not like terms. That's how your answer would look. And they didn't give us any measurement unit, so we just are going to say square units or units with a superscript 2. There's your assignment and how to do it perfectly. I'll see you next time.